Good morning, all of you. I am Dr. Vishnu Kumar Mishra from Mallareddy Women's College, MRECW. And today I will deliver the topic data structure and algorithm. And so, first I will deliver what is the data structure and then what is the algorithm and how we can build the algorithm with the data structure. So, data structure is nothing, we can store the data in such a way so it will be make the easy for the searching purpose, for sorting purpose, or whatever the operation we want to along with this data we can easily access the data. So data structure means we can arrange the data according to that, so it will be easy to us, we can search the data according to our convenience. So the storing the data in our convenience, that is known as a data structure. And already we have the so many algorithms is there for storing the data in particular database or the computer system. And that is a, you can choose any algorithm according to your choice. So suppose when we will cover the unit wise slowly, so you can get the different algorithm how we are storing the data and how we are searching the data for the accessing the data structure. So now, so already in the previous classes already I covered actually what is the algorithms, how it will be work. So in this lecture I will cover the stack ADT implementation. So already we know when we are talking about the writing a program of any algorithm or data structure, we have the two options. Either we can go for the stack or we can use the array. So when we are using the array, obviously array is a continuous memory location, stack is a continuous memory location. So when we are talking about the continuous memory location, we can store the data in the two different, store the data in such a way. So we can use a program in the continuous memory location. Another option we have when we are writing a program, that is a linked list. In the linked list what happens, it is a non-continuous memory location. We can store the data in such a way in the algorithm, so data can be stored anywhere of the memory location, but when we have finished our program, when we are going for run the program, automatic they will search the data and they give the output. So that is our main aim. So when we are talking about the stack, so when we are talking about the real life example of the stack, so if you see the files of the book, suppose the book we are keeping one by one like that. So what happened if you see, so the book which came the first, that will be the actually the your when we are accessing the stack concept, it will be the last one. When we remove the data from the stack, so the book came first, that will be removed in the last, and that concept we are calling, that is known as the last in first out. So or first in last out. So there is a two concept is coming here, last in and first out, and first in last out. So when we are talking about the stack, so stack is generally when you see, so first it comes, so in last we can remove. So last in first out, LIFO. So again we have the so many examples. If you see here, I have already given, suppose I want to remove this book. So what happened, if you see, so this book came first, then we have keep the second book, then we have keep here third book, then fourth book. But the last book what we kept here, it will be the remove first, and the first book who came in our queue in stack, they will be removed the last. So that is the concept behind that. And when we are talking about the working of the stack, so how it is working, so if you see actually, so what happens, suppose if we will take the size of the stack, that is 5, and we have the 5 stack of size. Suppose I want to enter the first element, that is 1. So suppose I have push, when we are entering the element in the stack, that is known as a push operation, and when we are taking out element from our stack, that is known as the pop operation. So when we are talking about the push operations, so what happens if you see, suppose I want to enter the first element, so the one will be, so one will be entered in the first one and it goes to the bottom. Now after that we have added a 2, after that we have added a 3, after that we have added a 4, and last we add a 5. So if you see, so now the first element came 1, and after that 2, 3, 4 and 5. But suppose if I want to pop up, so push we have done the 1, 2, 3, 4, 5 manner, but when we are popping the element, obviously it is not possible we can directly delete the 1, because it is in the last element now, if you see the carefully. So what we need to do in the pop operation, what we need to do, first we need to delete the 5, then we need to delete the 4, then we need to push out the 3, then I will need to push out the 2, and then I will need to push out the 1. So that is the concept for that. Now when we are talking about the operation, how the push operation is working, so what happened, before inserting the element of the stack, we check whether the stack is full or not. So obviously suppose the size of memory is, suppose your size of memory of your computer system is suppose taking 10 program or 20 program. Same like that, you think about that. Suppose the stack of size is like that, we can store maximum 10 value. And after that, if I will store the more than 10 value, what happen? Now it will be the overflow condition will occur. So overflow, what is overflow? Because now we have no space to enter the or push the value in the stack. So what we need to do? So now we need to check if it is a overflow condition, we stop to insert the element. So what we need to do? Either we can push the element, or without pushing we can't enter the element. So that is a condition. So once we are entering the element in the stack, so first you see either it is full or not. So when we are checking that it is full or not, if it is not full, so we can start to enter the element in the stack. Otherwise the overflow condition is coming. If you see the second point. Third point, so what happened? So initialize, what we do in starting, we can set the value that is a -1. -1, what happens? Suppose your size is full. So again we need to delete the element, and we need to, or suppose it is empty also. Suppose it is empty also. So if you see this is empty, so what is the memory location of this particular point? Because when we are talking about array start with the indexing 0. But when we are talking about the stack indexing is not a 0. It is start with the either 1 or like that. So what happened? We need to set it such a way so always it should be goes to the increment. So what happened, if you see now the stack is empty, and here what we need to do, we have given the value top is the -1. -1 means it shows that now stack is empty. Once the stack is empty, now what we need to do? Now we need to do the increment. And look here, suppose if we do the 1 increment, so what happened? Now I get the memory location 0, because -1 plus 1. So look here what we are doing, top plus 1. We have set the value -1. So now when -1 plus 1 we get, now we get a position 0. And once we get our first position, now we can push the element in the stack. Same we need to do for the second element. Now go for the top plus 1. So now this is the top. Before that, because top is -1, now this is the top. Then top plus 1 again you are doing. So top plus 1 is 20. Again top plus 2. Again that is the 30. Like that we need to increase the top. And what happened again? In the last we have set the max size. So now suppose your stack is full, size is full. So what we need to do? Now we can stop our. So if it is a max, means our size is full. So thank you all of you. The next slide I will go for the next lecture we go for the pop operation. So thank you all of you.